test, there's not really much advantage of doing them out of order here. First few questions say to solve by factoring. That's nice. It's telling you that, hey, you got to factor and you just got to choose one of the approaches here. When you look at number one, does anything stand out to you as far as the type of problem that it might be?
It's a equals 1.
Yeah, so two numbers that multiply to 20, but add to negative 12. That means they're both negative. So maybe the most time consuming thing there is to come up with those two numbers. Any idea what those are right offhand?
-2 and -10.
You got it. So you can write x minus 2, x minus 10 equals 0. And then you will be setting them both equal to 0. So x minus 2 equal to 0, x minus 10 equal to 0. Is that okay?
Yeah.
And then you solve for x. So the first one you add 2, second one you add 10, x equals 2, x equals 10.
Yeah.
Okay. That's, kind of the best one because it's just right there in front of you. Let's take a look at number 2. All right, so what I see here is two terms. Any idea of what this is or what you might remember from this one?
I think it's difference of squares.
So two terms, it could be difference of squares. They'd have to both be perfect squares. And like for 5, I don't see perfect squares. Same with 30. There's another possibility. There's always the one that you're supposed to start with from the very beginning.
GCF.
GCF, yeah. So in this case, it's 5 and then an x that goes into both. So could you tell me what goes in parentheses there?
Sure. X minus 6.
Yes. Now you said each of these equal to 0. Now the whole thing 5x is a term, same with the x minus 6. So you're setting 5 times x or 5x equal to 0, and then x minus 6 equal to 0. What would the one on the right be? What would it become?
X equals 6.
X equals 6, good. And then divide by 5, x equals 0. Let me know when you get that down. We'll move to number 3.
All right, got it.
Okay. So for number 3 here, it's different than the previous ones. There's stuff on both sides of the equation. If you look back at 1 and 2, you'll notice that they both equal 0 when we've been solving them. So the choice here is to move this minus x squared left, or to move the minus 3x and the minus 18 to the right. we want to move left, but the more important reason for why is because we really want that leading term to be positive. We want it to be positive 1x squared minus 3x minus 18 equals 0. So you'll see that on the test there. When you're solving, you generally set it equal to 0. All right, so this now is it's back to an a equals 1 type. So looking for two numbers that multiply to minus 18 but add to minus 3. Why don't you give this one a try, please, and let me know what you come up with.
Negative 6 and 3.
Okay, so that becomes x minus 6, x plus 3 equals 0. What are the two solutions that come from this?
X equals 6 and x equals negative 3.
Very good. All right. So the last one in this first grouping, solved by factoring. So it's already set equal to 0. That's good. No changes there needed. There's a number in front of x squared. That's not always good. That kind of was like number 2 here, where there's a number in front of x squared. But unlike number 2, there's nothing to factor out. There's no GCF here. So unfortunately, it's the grouping one where you have to take this 12 and multiply by the minus 10. Okay, so that's minus 120. What can you tell me in your own words what you're looking for here now that you got this minus 120? You don't have to give me the answer, just tell me verbally what we're trying to accomplish.
A number that multiplies to 120 but adds up to 7.
So negative 120
or negative 7
and negative 7. Yeah, it's a small distinction, but it is important here. So it's either negative 15 and 8 or 15 and negative 8. Which one would it be here?
Negative 15 and 8.
Yeah. Okay. Now the choices here is to when you break apart the minus 7 is, in this case, it'll become plus 8x minus 15x as sort of a preference over the other direction there. And do you remember what to do from here? What would be the next thing to
Put a line down the middle and find the GCF of the first thing.
First two, perfect. Yes.
Got 3x plus 2.
Okay. What did you factor out? What goes outside the parentheses? Because you said what you said was right inside.
4.
4x. Yeah. Yeah, you can't tell me what's correct inside if you don't have that. So I knew you knew how to do that. So this becomes 3x plus 2, and then what goes outside here on the left?
-5.
-5, good. So 3x plus 2, 4x minus 5, like that. Set them both equal to 0. So this one will take the longest, but you know how to do it. You know all the steps. You did most of this, without really any help from me. Can you give me the final answers here?
Sure. X equals 5/4 and
Good. How about the other one?
X equals -2/3.
Yeah. Perfect. All right, let's move on to number 5. So these just say to solve. They indicate that there could be roots involved because I think it says here to simplify all radicals.
Yeah.
Notice there's only one x. I mean, there's an x squared, but there's only one x or x squared in it.
Yeah.
And that's important. Your goal is to isolate the variable, or the x squared in this case. So you do that by adding 21 to both sides and then dividing by 3, because now you have that x squared is by itself. From here, you would take the square root of both sides. Square root of x squared plus or minus the square root of 12. So this is where you have to remember how to reduce the square root of 12. That's what it's talking about there, where it says, or indicating when it says simplify all radicals. What do you remember about this square root of 12?
Trying to. One sec. Okay, it's 2 square root of 3.
Very good. So it's plus or minus 2 square root of 3. Any questions on that?
No.
Okay, 6 is very similar. I'll just point out that there's only one x. It isn't squared, but it's inside something that's squared. So when it's in this type, you have to undo the square. You would not FOIL this. Like, don't you want to, and I'm not trying to, if you're even thinking that, but you don't want to FOIL this. You want to undo the square first by taking the square root of both sides. So this becomes x minus 2 equals plus or minus 9. Do you remember what to do from here?
Got to do the two separate things.
Yeah, two separate equations here. One's positive 9, one is -9.
So x equals 11 and x equals -7.
Yes. All right, let's move to number 7. So this one kind of looks like number 5, meaning that there's an x squared in it. You want to isolate the x squared. So to do that, you will divide both sides by -5. X squared equals -9. Do you see any problems with this or anything bother you about this?
In order to square root it, I feel like remember my teacher saying there's some like about square roots and negatives, they don't
Yeah,
go well.
like if we look at, I'll give you the answer here. Square root of 9 is 3, but it's because 3 times 3 equals 9. The square root of -9 is not -3, because -3 times -3, what does that actually multiply to?
Yeah, still 9.
Still 9. Okay, so that's a problem, right? Now, I think you mentioned talking about this, so I'll just work it out here on the left. It's on the left, you take the square root, you get x. On the right, treat it as the square root of -1 times the square root of 9. And then you break that apart. Oops, sorry, that's written really poorly. Wow, I can't believe I did that. Plus or minus the square root of -1 times the square root of 9. The square root of -1 is written as I. Did you see that?
Yeah.
Okay, so you do have to remember that it only applies to negative square roots. So the square root of -1 is I, and the square root of 9 is 3. Your answer is plus or minus 3i. So I don't want to say this, the number goes before the I.
Okay.
Any questions on that?
No.
Okay. All right. Let's look at number 8. Number 8, you know how to do. It's a lot like what we did in 5. You're reducing the root here. So do you remember what number you always start with when you reduce roots?
Usually 2.
Yes, and 2 doesn't work in this one, so you move to 3.
That does work.
It does work. And then you try it again, but this time 3 does not work.
4 doesn't work.
So you actually go to 5. You want to try prime numbers, not even numbers, because it's only the primes that work in this.
So it'd be 5 square root of 3.
Yes, perfect. Very good. Any questions on that?
No.
All right, so just in the interest of time, let's go to 10 because it's different. Nine is like what you've been doing. So this breaks apart into two square roots. It's really the square root of 49 and the square root of x to the 26th. So the square root of 49 is 7. It's a perfect square. Do you remember the rule for x to the 26th?
I think it's the numbers basically cut in half.
Exactly. So that's x to the 13th. All right. All right, I'm going to do 12 first on the next list here because it's kind of more like 8 and 9. I guess in some ways. There's a property that allows you to break apart the square roots. So it's the square root of 9 over the square root of 49, like that. And then if it works out, you just take the square root of each.
Huh.
Sometimes it works out nicely. All right, let's go back to 11. So 11 is really more of the rationalizing type. Well, 12 really isn't. I don't know why it's in that category. So the idea here is that you can't leave a square root in the bottom. Like whenever you see a square root on the bottom, it like isn't pretty. It doesn't look right. Do you remember how to rationalize or how to undo that square root on the bottom?
Oh.
So we're going to multiply the top and bottom by the square root of 6.
Oh, okay.
And the reason that works is not because of what happens in the top, it's because of what happens on the bottom. The square root of 6 times the square root of 6 is the square root of 36, and that's a known value. The square root of 36 is 6. And you should look to see if you can reduce here the numbers in front.
It'd be 2/3.
2/3, yeah. So you do have to do that. You can never reduce inside, like you can't put the 3 inside the root to reduce with that. So just on the outside. Okay, so 13 is kind of a combination of 11 and 12. You first will take the square root of the top, square root of the bottom. Three over square root of 5. And then I'd like you to try working this one out from here, rationalizing it like we did in 11. And if you can reduce, you try to, but sometimes you can't always reduce. So take a look at that.
I don't think I can reduce square root of 5.
Nope, this just becomes 3 square root of 5 over 5 like that.
Okay.
So sometimes you can, sometimes you can't. No, there's, you can sort of look ahead, but not always. Okay, ready to move on to 14?
Yeah.
All right. So we're completing the square. It says thou shalt complete the square here. Because it's a graded, paper test, you can't really get out of doing that. Teachers trying to indicate there's these boxes here that we're going to fill in. I showed you kind of going down vertically and then coming back. You may have seen it differently in the classroom. Really doesn't matter as long as you can do it on the test. Do you remember anything about this or how to go about
Honestly, I don't remember.
okay. Sounds good. So the number that goes in parentheses down here is based on this number in the middle. So it becomes x plus 3 squared. And then the number that goes back in the red is based on this number here. So you take the number and you divide it by 2 or cut it in half, and then you square it. To get back to this in the red here, so it'd be plus 9 and plus 9. So you have to somehow get that process down. Divide by 2, square it there. All right, now this is a problem like number, let me go back and look for it, number 6. This is like number 6. Can you go back and look at that and see what you did there?
Got the square root of both sides.
Yes. So it becomes x plus 3 equals plus or minus the square root of 16.
Yeah.
So it becomes like the case 1, case 2. You get 4 and -4, and you have to solve them both.
X equals 1 and x equals -7.
Yes, very good. So let's go back and summarize here. The completing the square is you take half of this number, put it down here, and then square it, put it back in where the red is, put it on both sides. Then it becomes a problem like number 6. Okay. Now it doesn't always work out nicely, so we'll see that in 15 here. Let me snip that in. But it is the same process. Okay, so you let me put those red boxes. So you got to take half of 12. What does that become down here in parentheses?
6.
Yeah, x plus 6 squared, and then it's plus 36 plus 36. So the right side is no longer like a you can't take a perfect square root of those numbers. So square root of both sides though, x plus 6 squared plus or minus the square root of 37. So it becomes x plus 6 equals plus or minus the square root of 37. So unless you can break it apart and it becomes a perfect square root, you just leave it. You don't have to do anything here. Now, like let's say it was the square root of 12, you would reduce that, but the square root of 37 isn't reducible. So when you subtract 6 here, you just put that right up in front. Minus 6 plus or minus the square root of 37, like that.
Yeah.
All right, let me know when you're ready to move on to 15.
I am ready.
Okay, so we're up to quadratic formula now. Do you know if you'll be given the quadratic formula on the exam?
Probably.
Okay. And what's your plan if you find out that it's not going to be given?
I'll just write it down on a note card.
Okay, I like that answer. Okay, so it's ax squared plus bx plus c equals 0. The quadratic formula is minus b plus or minus the square root b squared minus 4ac all over 2a. A is 1, it's the number in front of x squared. B is 6, and c is -7. So it does take on that operator there. All right, so the place where most students go kind of have trouble here is with this part under the square root. So would you mind calculating just that part for us here off to the side, and let me know what you come up with? Just see if there's any issues with that calculation.
We're at 64.
Yes, it should be. This one actually is a perfect square there. 6 squared minus 4 times 1 times minus 7. So it's 36 plus 28, which is 64. Perfect. Very good. Okay. So you might consider doing that off to the side rather than trying to do it all at once here. So this becomes minus 6 plus or minus the square root of 64 all over 2 times 1. The square root of 64 is a known value, so that's nice. Minus 6 plus or minus 8 over 2. So this becomes two values. You have to work them both out. Minus 6 plus 8 divided by 2. Minus 6 minus 8 divided by 2. And keep in mind the top's in parentheses, so you should do that part first.
I got 1 and 7.
Okay. On the right though, it's -7.
Oh yeah, -7.
Yeah, that'd be a small deduction there, but not too bad. Okay, let's look at number 16. Is this about how long your test would be? Like 16 questions like this, 2 or 3 pages?
Sometimes it's like more like 20 questions.
Ooh, wow, brutal. Okay. This one again says to solve by quadratic equation. Can you tell me the values of A, B, and C?
A is 1, 2, or B is 12,
Okay,
and C is -1.
good. Okay. I'd like you to calculate the B squared minus 4AC again.
$148.
Yes, perfect. Okay, so now, unfortunately, this is not a perfect square. 12 squared is 144, but it's not a perfect square. So we're looking at a situation where you have to reduce the root, unfortunately. So I recommend setting it up, go ahead and entering those values into the formula here. And then coming off to the side, and in this case, you have to reduce this root here. So do that together here. It's 2 and 74, 2 and 37. 37 is a prime number. That might be another thing to throw on a note card is some of the prime numbers if you've got room there. but in this case, a 2 will come out. So the this becomes minus 12 plus or minus 2 square root 37 all over 2, like that. So this time we have to divide each of these numbers by 2 in the numerator. And just like when we were rationalizing, like you can't take that 2 on the bottom and do anything with it inside the root, only the number out in front there. So this becomes -6 plus or minus the square root of 37. Let me know when you get all that down.
Got it.
Fantastic. So I just want to quickly show you that 14 and 15 are exactly the same as, I'm sorry, yeah, 14, 15 are the same as 15 and 16. I guess that should be 16, 17. The reason I'm showing you that is you actually can use more than one method to solve a problem. So why would I bring that up? You first of all, you do have to solve it the way they're telling you, like you have to do it that way. But if you ever want to check, like for example here, you could actually solve this one by factoring. Okay. And you get 7 and -1, and that's exactly what you found before. But that's only if you've got time. I mean, please do it the way that they suggest on the test there. Okay, so I think we got one more problem, number 9, to look at. Does that look right to you?
Yeah.
Okay. So just enough time to get the last one in, hitting the goalpost here. So we got 200, 2 and 100, 2 and 50, 2 and 25, and then 5 and 5. And just circle pairs. And you see what you bring out. You bring out a 2, a 2, a 5, and you leave in another 2. So it's 2 times 2 square root of, sorry, 2 times 2 times 5 square root of 2.
20 square root of 2.
Yes. And that is your final answer.
All right.
All right, so we'll go ahead and stop here for today.